Forms a little bit from diagrammatic to the actual structures. Okay, 1 point linear perspective, here we go. So first thing we need is a horizontal line. What is this horizontal line? This horizontal line is your eye level in space. Look at the wall in front of you, right? Imagine there's a mirror on that wall, just flat on the wall, or imagine the entire wall's a mirror. Your reflection in that mirror, where you see your eyes, that is your line of sight. This is your eye level. So I'm gonna place a point here. You could place it wherever you want. It could actually be off your paper, but for the sake of this tutorial, that would be kind of silly. So let me place it here. And when I do 1 point perspective, I like to draw a little eyeball just to drive home the point that this is not only a reflection of your own eye in that mirror in front of you, or if this is infinitely far in the distance, you got to imagine an infinitely far away mirror with your reflection in it. And you're closing one eye so that you just have this one eye reflected back, okay? All right, so here's your vanishing point. That vanishing point is not an abstract thing. It is your eye, your position in space. 1 point linear perspective is not about looking at things from an angle, from a corner. 1 point linear perspective is about looking at things dead on. That means we're going to start with a rectangle, or a square, and we can draw more complex forms, but even when we do, it's helpful to start with a rectangle or a square. Nice right angles, keep it nice and simple, right? All right, so let's look at this. This is our line of sight. So let's put an object up here. So we have these nice right angles here, nice parallel sides, right? Roughly parallel. And then here's my vanishing point. Let's get that blue pencil, but I'm gonna shoot this over to those corners. Now, some of you might prefer to use a ruler for this. I think it's better at the beginning just to like rough it out. I'm kind of a fan of rough, messy drawings at the beginning, and then you clean them up later if you need to. I have another corner up here. Why didn't I connect that? I could have connected this corner, but I'm assuming this is an opaque object, an opaque plane of an object, one side, and I can't see through it. So I didn't need to do that one. Now, this is fine, right? I got my line of sight, vanishing point. I got my orthogonal lines here. So I like the term line of sight instead of horizon line because you don't always see the horizon. If you're looking straight up, you can do a 1 point linear perspective drawing. If you're looking straight down into the center of Earth, if you're out in a spaceship, you could do a 1 point linear perspective drawing. You don't always see the horizon. So that's the point. So here we go. Step 1, vanishing point on our horizon. Step 2, draw our shape. Step 3, connect these orthogonal lines. Step 4, all I'm doing now is capping this form. And when I say capping the form, I mean use just a vertical line on this side, right? Because I don't need any diagonal lines other than what my orthogonal lines are telling me. I just need a vertical line, keep it parallel with this. It's just saying this form exists in this area, okay? Doesn't go beyond this. And then underneath here, I have another surface and I need to keep this as much as possible horizontal. That's going to intersect my orthogonal around here. And there we go. Something like that. I'll shade in the bottom here a little bit. Something along those lines. All right, so I can always go back with my string or ruler and I can check that vanishing point and I can swing this around and double check my angles and make sure those are looking good. Let's drop another form in behind here. This form is going to extend beyond my below my line of sight. And let's say it's going to extend up here above this form. And I'm going to cut it down here, actually. Whoop, right through here. Maybe it's got a little foot over here. Why not? Let's run with my mistake. Now we got to get back to those corners. Zip, zip. I got another little corner over here, my mistake corner. Let's cut over to it. Zip. And then we are shooting up to this edge, right? Okay, so other flat form. It's got a little funny foot over here. Who cares? It keeps it in line with the same thing that we started with over here, that we're looking at something dead on, nice flat parallel lines and right angles here, okay? So this also we need to cap somewhere, and we're capping that just with one vertical straight line. We're keeping that parallel with the line we already drew here. This object is above my line of sight. That's why I can see a little bit of the bottom. This object splits the difference here. It's above and it's below my line of sight. So I cannot see the bottom, I cannot see the top. So the kind of forms that I'm drawing here, these are basic blocky forms, right? Like think of modern architecture, nice right angles, lots of parallel edges. Think of the kind of architecture you see in most cities. Streets that kind of are set up on a grid work really well for this. Boxes, packages, tables, things like that. You can also draw things that are more organic and complex, but it helps even when you're doing that to have this kind of model in your mind of this basic blocky form. I think linear perspective, in my opinion, in my humble opinion, kind of maxes out when you start to make the forms a little more complex. Like we can take this, we can carve, we could draw the other side of this box over here, and we could put a cylinder in this box. We could put a cylinder here. We can use this basic blocky starting point to draw rounded forms, but we have to start with this basic blocky level. The more complex and organic the forms are, like you can put a human figure in basic blocky shapes, put the hips in one block, the ribs in another block, the head's in another block. You can kind of break down the figure into these basic blocky parts, and it is helpful to keep in mind these ideas of linear perspective when you're drawing the figure. At least I would argue 1 point linear perspective. But the more complex and organic the form is, like if you're thinking, how can I draw this tree or plant in linear perspective? And if you're out in the woods on a hike, you don't need to worry about linear perspective. But if you're in the city and you're trying to capture a street that you're looking at, or if you're in a room and you're trying to draw an interior and you want that sense of accuracy to your drawing, having an understanding of these basic concepts is super important. Let's do one way below my line of sight. So let's get our orthogonal lines going back here. Drop my vertical lines down. Let's carve it out a little bit more, and let's cut a piece out of this. Let's cut down to this corner here. So we're going to draw this kind of extruded triangle here. In order to do that, I need to take this corner that I have here, cut it across, take this corner here, cut it down. So what I'm trying to do is turn this into a semi-transparent form with this edge back here being the back edge. So I put these in here just as a guide so you could see a little more clearly what I'm trying to do, which is to connect this edge to this edge. And I'm imagining this form that I'm drawing has parallel edges along the bottom here, but it's sheared off. We can't really see the bottom of that shape due to the perspective that we're looking at it at, but I wanted you to feel that the footprint of this box, this blocky form that we've now kind of sheared off here, moving back in space. Let's carve out some of these forms as well. How do we work inside of here? Well, we have to do what we did over here. We need to draw that invisible other side. So first I need to connect this corner, which I did not originally connect. What I'm missing though is the horizontal line that cuts across like this. So this is my underside of my block. And now I'm kind of seeing through this, and I can start to divide this up a little bit to give myself some guides here as to where that cylinder would be hitting the edge of my form. And I need to also have that on the back here. So here's a midway point here, midway point in here, and a midway point over here, midway point over here. So again, kind of lightly drawing through the forms. And the edge that we would see here should be something like this, and the edge that we would see here should be something like that. So let me darken this up a little bit. A useful thing about this though is because I drew through it, I can see where that other side would end, right? Okay, so here are some examples of how you can work with linear perspective. I want to point out a couple other things here. One is that if this was a building, for example, all of the windows of that building would be following along with those vanishing points. So if you have smaller elements in here and those elements happen to be parallel with the larger object that they are a part of, then they of course are also going to follow that same vanishing point. So before we get into a couple other little common mistakes that I've seen students make, before I show you those, I just wanted to say the main takeaway from all this is that you have a line of sight, you have a vanishing point, and then you have objects that are connected to that vanishing point using these orthogonal lines. Okay, so the most simple way we can represent this is we have a y-axis, we have a z-axis, and we have an x-axis. The z-axis moves back and forth in space, the x-axis left and right, and the y-axis up and down. You are always in the center of these coordinates, okay? So your vanishing point, left or right in space, depends on where you are at. What's happening with linear perspective is we are first saying we need to worry about y and x-axis. So if it helps you, go ahead and add those same arrows, to your extending out from your vanishing point and off to the left and right of your horizon line. That's what we're talking about with x and y axis. Now z in on a plain sheet of paper like this, what we're saying is we are not moving into that space. The paper's two-dimensional. We are creating the illusion of two dimensions. And how we're creating that illusion of two dimensions is that we are extruding these forms on the z-axis. They must meet at the vanishing point. Where's the vanishing point? The vanishing point is infinitely far ahead of you, but it is you. It is your reflection infinitely far away. Take that and run with that in the most philosophical way that you want to, but that's where your vanishing point is. It is absolutely relative to you. It is not an abstract other thing. It is you, your reflection, one eye closed, infinitely far away. Or if you're in a room and you got a mirror right in front of you, close one eye, boom, there's your vanishing point. That's exactly where your vanishing point is. It is your perspective. It is your position in space based on your coordinates in space relative to other objects. Got it? Great. Let me show you a couple other common mistakes I see with one-point linear perspective. Now, one of the things I've seen students do is they'll draw a road, draw some trees down here. What the heck is wrong with this drawing? Okay, so if this is the horizon line, let's put some mountains back here. Mountains, mountains, mountains. Okay, vanishing point here. This seems like it's perfect, right? What's the big deal? So here's the problem with it though. If I'm standing on this road and not like floating above it. Now, if I'm in a helicopter, that's one thing. Okay, so if I'm walking down this road, I can't be taller than the trees and shorter than the trees at the same time. So there's some kind of confusion happening between I can see the trees and I'm looking down at them, and then I'm also seems like I'm looking down at the road as well, but somehow I'm also supposed to be walking in this space. Okay, so what would be happening if we override this drawing a little bit, if I'm standing on the road and I took some measurements, I'd probably see that the road occupies most of my field of vision. So I'm going to pull the road towards me like this, right? And probably the yellow lines in the middle of the road, they're probably going to look pretty big in this area very close to me and get smaller and smaller and smaller as they're moving away from me. Till that looks like just like one yellow line probably moving away from me. And then again, if these trees are lining the side of the road here, the trees themselves, let's say they're all roughly the same height, are above me, not below me, above me. So how high above me? Well, if they're like full-grown trees, probably fairly high above you. Let me just block in like the side of the trees if we do like some kind of Minecraft style tree here. And I am not using a specific method here for how much to space these trees out. I'm just trying to give you a sense that they're closer and closer together as they move away. There is a way you can do this mathematically. So here I am looking out. I'm standing on the road, or actually fairly close to the road here, maybe crouching on the road even, but the trees are above me. I can't somehow be so much bigger than the trees and above the trees and also have my line of sight somehow very close to the road at the same time. Okay, actually I could probably leave those mountains pretty much where they are, and because they're so far away that you're not really going to see the differences that I'm talking about with some of these up close objects. So they're granted a little bit of a right to stay where they're at, actually. So I'll just shade them in a little bit to show you those kind of sitting there in the background. How far all of this stuff extends, if it starts looking weird to you, it's probably because it's extending so far from your vanishing point that it's beyond your field of vision, that you would otherwise have to like turn your head to see those things. So there are limitations, is what I'm saying, to one-point linear perspective as well. And one of those is just exactly what things start to look like when they extend beyond a reasonable kind of field of vision. I'm going to show you one more thing here. Now, here's the other common mistake that I see students do a lot. So let's say we're in a room. Here's the wall of the room. Let's pull the room towards us here. So I'm going to kill two birds with one stone here. I'm going to show you a common student mistake, and I'm also going to show you something I should have shown you on that first drawing, which is that when you start with that flat object and you want to connect those corners to the vanishing point, the other way you can work with this is pulling the space towards you, meaning you hit those corners with your orthogonal lines, but they continue out this way. They fan out this way. I'm focused on rendering these out here. I'll make them darker to emphasize that. Here's the back wall, here's the floor, here's the ceiling, here's a left and a right wall. Okay, now this line of sight indicates that I'm kind of maybe standing in the space. I'm kind of equally spaced between the ceiling and the floor here. I'm going to give myself a couple guides here. These orthogonal lines are going to represent other students in the classroom, okay? So if I have a student, they're sitting on a stool, they're working on their drawing, they got a drawing board on their lap. Just a quick kind of gesture drawing. And their eye level's around here. I'll make that a little darker. So they're sitting on their stool over here. Let's say there's another student somewhere in the middle of the classroom, right? So what I did was, let's go ahead and use that stool as my guide for the bottom marks here. So here's a footprint of another stool closer to me. Here's the footprint of a stool farther from me. Let's drop another student right here. Now here's the thing. Let's assume all the students on the stools are the same height, and the students are the same height. So what's going to happen here? So in order to draw the, let's nail the top of the stool here, okay? Pretty close to that line. So if I kind of rough in where that stool was here. So here's the stool back here, here's the stool here, right? If the eye of the student is around my eye level, and let's say that the top of the head is, a little above that eye level, then this student sitting here is going to have to occupy something like this space. I could use, let's say it's more or less the same pose here. I could use this to give me some guides, right? Come out from that vanishing point, hit this elbow, proceed through here, and that will give me a good sense of where this elbow would need to be. So I'm kind of using this projection here to help me with some of these, copying this figure a little bigger here. Now let's put one more student close to us here. So close that in our field of vision, we don't see the bottom of their stool, but maybe we see the top of their stool. Let's rough that ellipse in. Let's drop it down the sides of the stool. Let's drop the sides of the stool down. Shoulder height has to be around here, right? Coming out from our orthogonal. Now, I find perspective drawing to be pretty dry. I don't think perspective drawing by itself is usually very interesting. What I think is interesting, though, is using perspective drawing to contrast other forms of drawing, such as gesture drawing. Put a gesture drawing in a really analytical space, and you'll get a kind of added boost to your gesture drawing, because the gesture drawing is going to look even looser and more energetic than usual next to those very rigid analytical lines, and your analytical lines are going to look even more analytical because, just due to contrast. Okay, so here's another student drawing. Boom, boom, boom. So here's the deal why this is interesting. You have these students in space. Their eye level is all basically lined up here with your eye level. Look how much bigger the figure gets when they're close to. Otherwise, if students don't understand this concept with linear perspective, they are very likely to do exactly what we just did with those trees and place everything lower and lower and lower in the space. I'll see something like this sometimes, and it's like, well, I can't be, unless this person's sitting on the floor, which they could be, but if this person is at the same eye level, they got to be way up here. They can't be down here. And we have this tendency, maybe from childhood or whatnot, of placing things lower and lower and lower on the page to imply this kind of spatial relationship. What we have to understand with linear perspective is that things that are far away, things that are close up, and things that are in the middle, if they share the same line of sight, they're all going to be around that same level. let's just put a very analytical but roughly sketched out floor into this space. Here are the students, and this student is incorrect, right? We don't like that. We want to slide that up so that it would match what we are seeing over here, if indeed the student is not just sitting on the floor. So that's my best shot at 1-point linear perspective, at least for the time being. And there's a really good question, which is why, right? Like, why do you need to know linear perspective? Do you need to know it? Linear perspective, for the record, it's just another tool to have in your toolbox. There might be times you want to use it. There might be times you don't want to use it. There's a lot more I could say about linear perspective. I think it's actually super interesting philosophically speaking, in terms of metaphysics, in terms of this idea of you being infinitely far away and infinitely intimately close up as well. That kind of bridge between those two is very interesting. The way it was used in early Renaissance paintings with the central figure, baby Jesus, Virgin Mary, etc., those figures being the vanishing point and all of the architecture pointing to them. There's a lot of very interesting aspects to how it's used. Actually more interesting than 2-point linear perspective, because with 2-point, it's not about you in the center, it's kind of these other 2 points off to the side. So that's my overall takeaway. If you can find a use for it, and I think if you're interested in life drawing, you absolutely will find a use for it, I would put it to use. A whole other video is really required about drawing from life with linear perspective, but the only thing you're really missing from this video I just did is just measurement. That's the bridge to doing this from imagination and doing it from life. It's just measurement. So that drawing I just did of the classroom, starting with 1-point perspective, I just need to know the measurements of that wall in general. What's the height to width ratio? And then I just need a rectangle that captures that on my paper. And then I need to check all the other angles and measurements inside of my drawing. But it's essentially following the exact same steps plus some measurement. That's about it. Thank you.